A very warm welcome everyone. Today in this class, we will be continuing the chapter Carbon and its Compound under the subject Science and Technology, Class 9, Unit 18. I hope you are prepared with all your notebooks and pens. So without further ado, let's get started. So let us start by recalling some of the stuffs we learned in the previous class. So let me ask you a question. So what are the sources of carbon we had studied in the previous class, like in which form it can be found? Yes, it can be found either as a pure elemental form, that is, that substance only is made up of carbon, or it can also be found as a compound in which carbon is attached with other elements to form that compound. So these are the two sources of carbon. Either it can be found as an elemental source or as a compound source. So can you guys tell me a few examples in which carbon is found in a pure elemental form? I hope you have mentioned a few that is written here. So in elemental form, carbon is found as graphite, diamond, coal, charcoal, soot, and graphene. Now, can you guys tell me the two categories in which the compound source of carbon has been divided into? Yes, it's inorganic compound or organic compound. So the examples of inorganic compounds are, they are carbonates, gases, bicarbonates, carbides, minerals, and stones. And since there were so many organic compounds that I have mentioned, so can you guys tell me a few of those organic compounds that contains carbon? Yes, carbohydrates, proteins, fats, petroleum, urea, LPG are certain examples from all those organic compounds we had studied in the previous class. Now let me ask you another question. What is the catenation property of carbon? Yes, catenation property is that property in which the atoms of same element it bonds with each other to form a long chain, and carbon also has this tendency to attach it with itself through a covalent bond, forming a long chain. It can either form branch chain or linear chain as well as ring chain, and due to this catenation property of carbon, so many materials, polymers are able to form. And there are so many materials that contain carbon in it due to this property, that is catenation property of carbon. Now we had also studied about allotropes. So do you guys remember what allotrope is? Yes, allotropes are those elements which has same chemical properties but different physical properties. So such type of elements are known as allotropes of each other. And we had also studied that carbon has many allotropes, and those allotropes can be divided into two categories. The first is the crystalline allotropes and second is amorphous allotropes. Now what was crystalline allotrope? Yes, those allotropes that had a definite geometrical shape and the atoms were arranged in a regular fashion. Then those type of allotropes was called as crystalline allotropes. And some of the examples of crystalline allotropes were, yes, diamond, graphite, and fullerene. Now what is amorphous allotrope? Yes, the allotropes that does not have a specific geometrical shape, the atoms are arranged in an irregular fashion, then those type of allotropes are known as amorphous allotropes. Now can you tell me a few examples of amorphous allotropes? Yes, those are coal, charcoal, soot, etc. Now let us study about the two types of crystalline allotropes a little bit. Let us revise the graphite and diamond. Now, as I mentioned earlier, in diamond, carbon atom has, not only in diamond, carbon atom has 4 valence electron in its outermost orbit. And in diamond, all those 4 valence electron, it binds with other carbon atom through a strong covalent bond, and they form a tetrahedrons. Now, we know that all these carbon atom form strong covalent bond. That's why diamond is the hardest substance, hardest naturally occurring substance known to mankind. And since all the 4 valence electron of carbon are attached or shared covalently with other carbon atom, it does not have any free electron. So due to absence of free electron, it is a bad conductor of electricity as well. But now in case of graphite, we had studied that out of 4 valence electron that is present in the outermost shell of the carbon atom, only 3 of them forms covalent bond with other neighboring carbon atom. Now, 1 electron from each atom is free. So due to the presence of that free electron, graphite is a very good conductor of electricity. Now, these were all the things we studied in the previous class. Now, let us study something new about carbon, the physical as well as the chemical properties. So, let us start with physical properties of carbon. Now, the first physical property of carbon is found in solid state. Now, these gold, soot, charcoal, diamond, graphite and graphene you can see here in this video, these all are in solid state. You can see that. And these all contains only carbon in it. So, from that we can say that carbon is found in solid state. Now, let me ask you the same question I asked previously. Out of all these 6 videos you can see, which are the crystalline allotropes and which are the amorphous allotropes? Yes, these 3 that is present on the above are amorphous allotropes, and these 3 are the crystalline allotropes. Now, another physical property of carbon is carbon does not dissolve in water. Now, let us check if this is true or not. Now, here I have taken the leads that we used to write in our lead pencils, and this lead is made up of graphite, which is carbon. Now, I have grounded this using my hand into powder form. Now, let us see if this dissolves in water or not. No. Let us stir it. Now, you can see it does not dissolve in water. Now, from this, we just proved the physical property that we just studied, that carbon does not dissolve in water. Now, what we saw is the powdered form of carbon. When we poured it in water and we stirred it, what we saw that carbon did not dissolve in water. So, from this, we can say that carbon does not dissolve in water. Now, another physical property of carbon is when carbon is heated at a very high temperature, it does not change from solid to liquid state, but it directly changes from solid to gaseous state. So, this is another physical property of carbon. Now, do you guys know the word for that substance that directly changes from solid to gaseous state without undergoing through liquid state? Yes, that is sublimate. So, we can say that carbon is a sublimate. So, when carbon is heated at a very high temperature of about 3500 degrees centigrade, it does not, from solid state, it does not melt, but it directly sublimes, that is, changes into gaseous state. So, this is another physical property of carbon. Another property is most of the carbon are black in color, but diamond is transparent. So, the main reason due to this is the geometrical structure. Now, in most of the carbon, their geometrical structure allows them to absorb light. So, you can see, like for example, you can see that this duster is red in color. Why? Because this duster absorbs all the light, all the colors of light that is present in the visible light except red. It only reflects red color, So we can see that this duster is red. But in case of carbon, it absorbs all the visible light. That's why it appears black in nature. But in diamond, what happens is, due to its structure, the carbon atom structure, it cannot absorb any light. So that's why it appears transparent. Now, the another physical property of carbon is carbon doesn't shine, but there is an exception to this property, that is diamond. Diamond is very shiny in nature. So this is due to total internal reflection. Now, how this happens is, now this is a denser medium and this is a rarer medium and this is the normal. Now, when light is passed from denser medium to rarer medium, what happens? It bends away from the normal. Now, this is angle of incidence. Now, if this angle of incidence is equal to the critical angle, then what happens? The light gets refracted along this surface perpendicularly. But if this angle of incidence is further increased, and if the angle of incidence is greater than the critical angle, then what happens? This ray of light, it reflects back in the medium, and this phenomenon is known as total internal reflection, and this happens in diamond. Now, why this happens is, the critical angle of diamond is 24.4 degree. You can say that it's about 24 degrees. Now, this is a very small critical angle, and most of the light that is incident has higher chances of being greater than this angle. So, when light is incident in diamond, what happens? This is rarer medium, this is denser medium, so it bends towards the normal. Now, this angle is greater than critical angle, that is greater than 24, then what happens? Total internal reflection occurs. So it reflects over here. Now again, the angle would be greater than the critical angle of diamond. It again reflects. Now finally, you can see that the angle of incidence is very low. Maybe it is less than 24 degrees. So finally, it will emerge out of the diamond. Now, due to this multiple reflections of light inside the diamond appears very shiny in nature. Now, another physical property of carbon is carbons are bad conductor of electricity and heat except for graphite. Now, in carbon, it has the tendency to share all the valence electron that is present in its outermost orbit covalently to its neighboring carbon. So, it does not have any free electron that is necessary to conduct heat and electricity. But in case of graphite, as I also mentioned previously, out of all those 4 valence electrons, only 3 of them covalently bonds with the neighboring carbon atoms, and each carbon atom has 1 free electron in its valence shell. Now, due to that presence of large amount of free electrons in graphite, it can conduct heat as well as electricity. So that's why we can say that carbon is a bad conductor of electricity and heat, but the exception is graphite. Now, another physical property of carbon is the density of carbon. It ranges from 1.5 gram per centimeter cube to 3.5 gram per centimeter cube. So, all the allotropic form of carbon has the density in this range. Now, we studied about all the physical properties of carbon. Now, let us study about some chemical properties of carbon. Let us begin with combustion. Now, combustion means burning in presence of oxygen. So, when carbon is combusted in presence of oxygen, what happens? So, the first thing is, if the carbon is combusted in presence of excess oxygen, that is, the oxygen is present abundantly in that reaction, then the carbon reacts with oxygen to form carbon dioxide. But if there is only little amount of oxygen, that is limited amount of oxygen is only present during that chemical reaction, then what happens is it does not form carbon dioxide. Carbon attaches with oxygen to form carbon monoxide when you have limited amount of oxygen. Now let us look at the chemical reaction. Now carbon, when it reacts with oxygen and the oxygen is present abundantly, then what happens? It gives us carbon dioxide. But the same carbon, it reacts with oxygen, but the oxygen is present in limited amount, that is in very little amount, then it gives us carbon monoxide. Now this reaction is not balanced. Here we have one carbon, but two oxygen here and one oxygen here. So now we have 2 carbon, 2. Now this is the balanced chemical reaction and this reaction is balanced. So this is one chemical property of carbon, in which when carbon reacts with oxygen, when there is excess oxygen it forms carbon dioxide, but when there is limited oxygen it forms carbon monoxide. Carbon with excess oxygen gives carbon dioxide, but same carbon, if there is less amount of oxygen, it gives us carbon monoxide. Now we also inhale carbon dioxide while breathing in little amount, and it is not that injurious to health. But when we inhale carbon monoxide, what happens? Now we all know that our blood contains blood cells in it, and the blood cells such as RBCs, red blood cells, WBCs, white blood cells, platelets, etc. Now those RBCs, red blood cell, it contains hemoglobin in it. Now when we inhale carbon monoxide, what happens is carbon monoxide has higher affinity to attach with hemoglobin. So what happens when hemoglobin is exposed to both carbon monoxide and oxygen, the hemoglobin has higher affinity towards carbon monoxide than oxygen. So carbon monoxide, it combines with hemoglobin. Now the main function of RBC is to transport oxygen from lungs and heart to the different parts of the body, then back to heart and lungs. Now if hemoglobin has already presence of carbon monoxide attached on its surface, then it does not have a place for oxygen to attach. So that hemoglobin will not be able to transport the oxygen because it would have attached with carbon monoxide, forming carboxyhemoglobin. So due to this, what happens is when we inhale carbon monoxide, hemoglobin that should have carried oxygen will not be able to carry oxygen. So in our body there will be lack of oxygen because oxygen would not be able to be transported through different parts of the body. Now if our brain does not get enough oxygen even for a short time, then we will start feeling dizziness, fatigue, and we would start being confused. And if there is prolonged inadequate supply of oxygen, then it will severely hamper our brain, hamper our heart as well as other organs, and we will die. So that is the reason why in winter season people say that you should not close all your doors and windows when you are burning those firewood to keep yourself warm. Why? Because when the wood is burning, it will take up oxygen. And in the room, if all the doors and windows is closed, that is, supply of oxygen is very less, then what happens? The burning of wood will intake all the oxygen that is present in the room. So there will be little amount of oxygen present in it, and during that state what happens is the carbon and oxygen reacts to form carbon monoxide, and then you will suffer from carbon monoxide poisoning and you'll have a very high chance to die. So you should always keep this in mind. Now to study further chemical properties of carbon, we have to study a little about little about reactivity series. Now, in the other chemical properties, I will be using the word reactive metal, less reactive metals. So you guys might be confused what that is. So in reactivity series, this reactivity series is a series of metal in which it is arranged in a series in such a manner that the metal that is present on the top is most reactive, and at the bottom is less reactive, and this is the reactivity series. So when I say, when I talk about reactive, highly reactive metals, then I'm talking about those metals that is present on the upper side of the reactivity series. And when I'm talking about less reactive metal, then it is those metals that is present in the lower side of the reactivity series. Now, another chemical property is reaction with metals. Now, when highly reactive metal, when highly reactive metal reacts with carbon, it forms metallic carbide. Now, let us study some examples of reactive metal. I'll take you an example of aluminium. Now, reactive metals such as aluminium, when it reacts with carbon, it forms metallic carbide, and in here it forms aluminium carbide. The valency of carbon is 4, valency of aluminium is 3. So this is aluminium carbide. Now this reaction is not balanced. Here we have 4 aluminium, here 1. So 4, we have 3 carbon, 3. Now this is the balanced chemical reaction. So from this we can say that when carbon reacts with highly reactive metals, it forms metallic carbide. Now we just studied about this chemical reaction, and some other chemical reactions are iron. When it reacts with carbon, it forms metallic carbide. Here it forms ferrous carbide. Lithium metal, it reacts with carbon to form lithium carbide, and calcium, it reacts with carbon to form calcium carbide. Now, let us study about the reducing property of carbon, and I want to ask you a question here. So, what is a reduction? So, what is reduction? I hope you answered it and answered any one of this answer. So, you can see that the phenomenon of reduction happens if one of these three occur. So, if an element or a radical, it gains electron, then we can say that reduction phenomenon occurred. Or if a certain compound, it loses oxygen, then also we can say that reduction phenomenon occurred. Or if certain compound or element, it gained hydrogen, then also we can say that reduction occurred. So if there is any one of these three phenomenon, then we can say that it is reduction. Now we will study about reducing property of carbon. So the first property is carbon, when it reacts with metallic oxide of less reactive metal, it removes the carbon from the metallic oxide and forms carbon monoxide, and it also gives us metal. So now here you can see that oxygen is removed. So loss of oxygen means reduction. So this is also a reducing property of carbon. So carbon, it removes oxygen that is present on the metallic oxide of less reactive metal, and it gives us metal and with the release of carbon monoxide. So let us take a few examples of it. Now let us take an example of ferric oxide. So what is the formula of ferric oxide? Yes, it's Fe2O3. Now, when ferric oxide reacts with carbon, it gives us metal iron with the release of carbon monoxide. Now, this equation is not balanced. Here you can see there is 2 iron, 1 iron. So 2, 3 oxygen, 1 oxygen, 3, 3 carbon, 1 carbon, 3. Now, this is the balanced chemical reaction. Now, here you can see that carbon, it removed the oxygen that is present in ferric oxide. So, you can say that This is the reducing property of carbon. We just studied about this reaction. So let us take an example of other reaction as well. When zinc oxide, it reacts with carbon, the carbon, it removes the oxygen present in this metallic oxide to form zinc with the release of carbon monoxide. Similarly, when lead oxide, it reacts with carbon, it gives us lead with the release of carbon monoxide. Now let us study about another chemical property of carbon, that is reaction with lime. So can you tell me what is lime? Yes, it's calcium oxide. It's written over here as well. So lime means calcium oxide. So let us study about the reaction of lime with calcium oxide. Now, when lime, it reacts with carbon, it gives us calcium carbide and carbon monoxide. Now this reaction is not balanced. Here you have 3 carbon, so 3, oxygen 1, calcium 1. Now here you might be confused to this structure because the valency of carbon is 4, calcium is 2, but why do we have 2 over here? So how the structure forms is, carbon, it has 4 electron in its outermost orbit, and another carbon also has 4 electron in its outermost orbit. And in this structure, what happens is, these 2 carbon forms a triple bond, that is, it shares 3 of the 4 outermost electron with each other. And calcium has 2 electron in its outermost orbit. Now for this carbon atom to reach the octet state, how many electron it needs? 1, 2, 3, 4, 5, 6, 7. So the carbon donates 1 to this carbon and 1 to this carbon. So in that way, carbon has 1, 2, 3, 4, 5, 6, 7, 8. This carbon also has 1, 2, 3, 4, 5, 6, 7, 8. And calcium, since it loses 2 valence electron in its outermost orbit, it reaches the stable octet state. And this 2 carbon also reaches the stable octet state. So this is the structure of calcium carbide. Now let us study about another chemical properties, that is reaction with steam. So when carbon that is heated at a very high temperature, that is of about 1000 degrees centigrade, to that hot carbon, if steam is passed over it, then that hot carbon, it reacts with the steam to form carbon monoxide and hydrogen gas. Now this 2 gas is collectively known as water gas. Now this water gas is also used to make fuel gas, and fuel gas is something that it acts as a source of energy, and it can also be transferred through pipelines. So water gas is also used to make fuel gas, and it is very important in the industries. Now, we studied about physical properties and chemical properties of carbon. Now, let us test our knowledge by trying to solve a few questions. Now, the first question I have for you is, which of the following is the correct molecular formula for aluminium carbide? So, the first option is Al4C3, second is Al3C4, AlC, AlCO3. So which of these 4 is the correct molecular formula for aluminium carbide? Yes, it's the first option. Al4C3 is the correct molecular formula for aluminium carbide. Now another question is, which one of these 4 options that I'll give you has a crystalline structure? The first option is coal, second is fullerene, third is charcoal, and the fourth is soot. So which of these 4 allotropes of carbon has a crystalline structure? Yes, it's fullerene. Now, another question. which one of the following is odd in the sense of conduction of electricity? So I have 4 options for you: soot, diamond, graphite and fullerene. So which is the correct answer? Yes, it's graphite, because the question asked which one of the following is odd. That means it is an exception to this to in the sense of conduction of electricity. Since we studied about the physical property of carbon, that carbon cannot conduct electricity, but we had an exception of graphite, that it can conduct electricity due to presence of free electron. So the exception that is odd in the sense of conduction of electricity is graphite. Now another question is, what is the range of the density of carbon? So I have 4 options for you: 1.5 to 2.5 gram per centimeter cube, 2.5 to 3.5 gram per centimeter cube, 2.5 to 4.5 gram per centimeter cube, and 1.5 to 3.5 gram per centimeter cube. So what is the density of carbon, the range of density? Yes, we studied that in the physical property, that the range was 1.5 to 3.5 gram per centimeter cube. So here the correct option will be the 4th option, 1.5 to 3.5 gram per centimeter cube. Now find the correct and the incorrect arguments from the following. Here we have 4 arguments, and let us access this individually to see which is correct and which is incorrect. Now the first argument is, carbon, when it is heated to a high temperature, it changes from solid to liquid state. So is this true? No, it's not true. Why? Because carbon is a sublimate. So when it is heated at a very high temperature, it changes from solid state to gaseous state without undergoing the liquid state. So the first argument is incorrect. Now the second argument we have is, loss of oxygen or the gain of hydrogen is called as the reduction property. So is this argument correct? So let me give you a hint about what we studied previously. So we said that we can only say if it is a reduction phenomenon if one of these 3 occurs. So if there is gain of electron, loss of oxygen or the gain of hydrogen, then we can say that it is reduction. And over here in the argument it says loss of oxygen or the gain of hydrogen is called the reduction property. So is this correct? Yes, it's correct. Now third argument, metallic oxide, when it is heated with carbon, it gives metal and carbon monoxide. So is this correct? Let us look back at our slide. So in the reducing property, what we studied was, carbon, it removes the oxygen that is present in the metallic oxide of less reactive metal, and it gives us metal and releases carbon monoxide as well. So here the argument says metallic oxide, when it is heated with carbon, it gives us metal and carbon monoxide. So is this statement correct? Yes, it's correct. Now we have the final argument. Water gas is a mixture of carbon dioxide and hydrogen. So is this true? No, it's incorrect. Why? Because when carbon that is heated at a very high temperature to its steam is passed over it, then what happens? It forms the mixture of 2 gases, that is carbon monoxide and hydrogen gas, and this mixture of carbon monoxide and hydrogen is known as water gas. But here the argument states carbon dioxide and hydrogen, which is incorrect because water gas is the mixture of carbon monoxide and hydrogen. So the first statement is incorrect. Now in this class we revised a few of these points that we had studied in the previous class, and in today's class we covered the physical properties as well as the chemical properties of carbon. So I hope you understood whatever I taught you today. So I'll see you guys in the next class.